Hey everyone. Uh, we're going to try to keep this kind of short since we think this is review for you. But this lesson on 2.6 is about ratios and proportions. And a couple things I want to just remind you of. A ratio is simply a comparison of two numbers by division. However, we can express ratios in three different ways, and I'm going to highlight them on here. So we can do x to y using the word to. We can use a colon, or in our class for math, we typically will use it as the fraction form, so using it with division. Also, ratios are always expressed in simplest form, and so that makes sure you always want to simplify your fractions. If two ratios are equal, then we call it a proportion. And we can determine whether two ratios form a proportion by expressing them both in simplest form to see if they equal, or we can check them using cross products. Honestly, I tend to use cross products just, I don't know why, because I do. I think it's more efficient sometimes, but maybe you'll disagree. You can do it however you want. So here we have an example. We're comparing 24/36 and 12/18 to see if they are equivalent. If I simplify 24/36, I get 2/3. If I simplify 12/18, I also get 2/3. So yes, those do form a proportion because they are equal. In the second example, we're going to use cross products. So when we set it up like this, 10/18 and 25/45, we're going to cross multiply. So we're going to do 10 times 45, and then we're going to do 18 times 25 and see if those equal. And since they both equal 450, indeed they are equal. Okay, so go ahead and try those 6 questions to see if you can determine whether they are equal or not. And we'll check those answers in class tomorrow. On the back side, to solve a proportion, we can also use cross products. And the one thing that you kind of need to know vocabulary wise is when we have a proportion, if we have A over B equals C over D, A and D right here are called the extremes. And that's because they're the first and last terms, or the first and last numbers. Then C and B are called the means. And that's because those are the middle ones. All right. Now, I personally don't know how important knowing that vocabulary is, but your textbook does use it. It might be used on a quiz or a test. So I will continue to use it, and you should know what it means, but I think I made it through my whole high school math classes and probably never really memorized that. Anyway, so if we want to solve a proportion like this one, we have x over 5 equals 10 over 13. We're going to cross multiply or use cross products. So I multiply my extremes, 13 times x, and I multiply my means, 5 times 10, and I get an equation 13x equals 50. And then you just solve the equation like we've been doing all of chapter 2. And we get a solution of 3 and 11/13. So go ahead and practice using cross products to solve these. But I do want to focus on number 12. Number 12 is a little tricky, so I want you to solve it, but then see if your answer makes sense or not. So I'm not going to tell you about it yet. We'll talk about it in class tomorrow. But there is something tricky about number 12. So see what you come up with, and we'll discuss it tomorrow. And finally, we use ratios when we use unit rates. So if we wanted to talk about a price per pound or how many miles we drive in 1 hour, that's a unit rate. We also use ratio in scale model problems. So see if you can attempt these 2 questions by setting up proportions and solving them. But you should have done problems like this before, so I'll let you try that on your own. Then the next lesson is about percent of change. Percent of change is really quite simple as long as you remember this ratio. In order to solve a percent of change problem, you're always going to take the change amount, or the amount of change, and compare it to the original amount. And that's important. If you want to just remember it as change over original, as long as you can do this ratio, you're absolutely going to be fine with these problems. Most of my students get messed up because they want to put the new amount in the denominator, and we do not want the new amount. We are comparing the change to the original amount, okay? If the new amount is greater than the original, then the percent of change is an increase. If the new amount is less than the original number, then the percent of change is a decrease. So here's two examples. If our original amount is 48 and our new amount is 60, we know that that's an increase, because to go from 48 to 60, that's an increase. To find the amount of change, we'll just subtract large number minus small number, and we get 12. So the amount of change is 12. So we set it up as a ratio. The amount of change is 12. In fact, I'm going to write this over here. So change over original. Why isn't it right there? There we go. Change over original. So 12 over 48. Now they set it up as a percent proportion. So 12 over 48 equals R, or P, percent over 100. You can do it like that and solve it like a proportion if you want. I have a tendency to solve it just like this. I would do 12 over 48. I just do the division, and I would get 0.25, and then I just convert it to a percent of 25%. So it's up to you whether you set it up as a proportion or whether you could just convert the ratio to a decimal. Take your pick. Okay, so that's a percent increase. A percent decrease is the same thing, only now remember our original number is decreasing to a new amount. We find the amount of change, which is 8. We set up the ratio, so the amount of change is 8 over the original amount, 30. And be careful here, this is where people want to do 8 over 22, but it's 8 over 30. You can set it up as the percent proportion, or like I said, I have a tendency to just do 8 over 30, convert it to a decimal, and I would get 0.26 repeating, and that becomes 26 2/3%. Okay, so try those on this page. See how you do. Those should be pretty simple. Then on the back page, we use percent of change sometimes when we're talking about sales tax and discounts. And a sales tax causes the total price to be a percent increase, whereas a discount causes the new price to be a percent decrease. And these are pretty simple. Just if we have an example here, the coat is on sale for 25% off. The original price is $75. What is the discounted price? So we simply take 25% of $75, which is $18.75. Now that's the amount of the discount, okay? So this is the discount. It's not the new price. It's just how much they're going to take off of the new price. So we have to subtract that from the original, and we get that our new price, or sale price, is $56.25, okay? So there's two like that that are discounts. 3 and 4 are discounts. 1 and 2 are sales tax, where we're going to just take 4% of 24 and find out how much sales tax that is, and then we'll add it to 24 because it's an increase. So give those a shot. Then number 7, we're looking for the percent of increase. So the original selling price of a new sports video was $65. Due to the demand, the price was increased to $87.75. What is the percent of increase? Give these 3 word problems a try. They may be a little bit of a challenge. We'll discuss them tomorrow to make sure you're setting them up correctly before you start your in-class practice, and we'll go from there. Have a great night.